What I have is the perimeter of a certain shape is given to me by this. Calculate the value of x which gives its minimum value. All right, now if I was to get, I tell sometimes the early level lads, because they sometimes, some of them might forget differentiation on the day. What I tell them is if you lob it into your calculator like so, you can actually check your answer before you begin. I'm just going to go from 0 to 20. Is that okay with you guys? Actually, 0 to 25, I believe I'll get away with. Right, keep going. What's the first one, an error? Why is x not allowed to be equal to 0? You can't have 0 as the denominator. Doesn't work. Okay. Nextly, we're going down. Keep going down until you hit your minimum value. And we're going to hit it. There it is there. I think it's 212. I think it's going to be x equals 12. But what do I notice? It's not symmetrical on both sides, is it? One of them is 112.7 and the other one's 112.6. It's not symmetrical, but it's in around the 12 region, right? X equals 12 and the answer is 212. That's great because I know that straight away, right? What we know is for minimums, the slope is equal to 0. Because I don't like doing the quotient drill, we're going to do x minus 1. Okay, you guys? Now, we're going to differentiate once, and we're going to put it equal to 0 because the slope is 0 at the minimum. So it's going to be minus 1152 x to the minus 2 plus 8, and that's going to equal 0. We're cool with that? Move it over to the other side, we're going to get 8 equals 1152 x to the minus 2. That x minus 2 can do what? What can I do with the x minus 2? I can put it over x squared. So we get 8x squared equals 1152. 1152 divided by 8. Square root it. Oh, the answer was 12. Right, that's grand. Why can it not be minus 12? Can't have a minus length. Okay. Then what do you do with your value of 12 at the end? Sub it back in, and you get 212 as your minimum. Really difficult, or what do you think? Well, it is only question 2. Well, yeah, it's not too bad. Okay. Now, let's have a look at question 5. Or 6 even. 6. Now, here's what I'd like you to do here. Okay? I want you to draw a box like so. Control D. Alright. And here's your box. Okay? Oh wait, keep it away from the other line. That'll just confuse people. It's a square, isn't it? So the length and the width should be roughly the same, okay? Now, what I'd ask you is, what is the height of my box? What's the height? Now, the height is x, because that's the way you're folding it up. That's like x, and you're folding up, so the height is x. Everybody cool with that? Now, what's getting taken away from the 12? You're deducting an x on this side, and you're deducting an x on the other side. So what does that mean? 12 minus 2x. And what does that mean about the other side? Also 12 minus 2x. Now here's what I want you to do. I want you to get the volume of the box by multiplying the length by the width by the height. Then I want you to differentiate it and show it has a maximum at x equals 2. Off you go. The video. P equals x by 12 minus 2x. 12 minus 2x. P equals x times 144 minus 48x plus 4x squared. P equals 144x minus 48x squared plus 4x cubed. And then we will differentiate this. And we will get 144 minus 96x plus 12x squared. Did anybody get that? For the first derivative? Okay, so when the slope equals 0 is when you either have a max or a min, because it's a cubic function. So we're going to get 12x squared minus 96x plus 144 equals 0. I would divide by 12 in your shoes. And I think you're going to get 6 and 2, are you? X minus 2, x minus 6 equals 0. X equals 2, and x equals 6. Now, does it ask me to prove that's a maximum? That's not enough, is it? How do I prove it's a maximum? That's second derivative and sub in 2. So you need to do the second derivative test. Sub in 2. And you get 24x minus 96. Sub in 2. And if it's negative, it's a maximum. If it's positive, it's a minimum. 24, 2 minus 96. You got minus 48, which is less than 0. This is in fact a max. The perimeter of a sector, so perimeter is 8. So what does that mean? I would say that it means that the two yellow sections, which are the radiuses, the two radiuses plus the arc is 8. Everybody cool with that? Now, what's the equation for the arc? R theta. So everybody therefore agree that the perimeter is 2r plus r theta is equal to 8. The two yellow parts are r plus r, which is 2r. The blue section is arc formula, which is L equals r theta. Add them together, you have to get 8 because it says the perimeter is 8. Are we all on board with the equation in the red box? Two radiuses plus the circular edge gives you 8. Alright? Now, I got to isolate theta on its own. So how do I isolate theta on its own? 2r. And then theta on its own? Yeah, I'm going to do 8 over r minus 2. So I can avoid the quotient rule again. Now, what we're going to have to do next is we're going to have to get the area of the sector. Where is the area of the sector formula in your notes? Is it a half r squared theta? I didn't teach you guys this, so I'm a bit rusty. I was out for it as a paternity leave or whatever. It is a half r squared theta, okay? Now, in that case, can't show that the area of the sector in square meters is 4r minus r squared. No bother. Here's what we're going to do. We're going to do a half r squared times 8 over r minus 2. Multiply it in. A half of 8 is 4. R squared divided by r is 4r. And then a half r squared with 2 is just r squared. Done. You know the great thing about a question like this is, if you can't do question 2, you can still do question 3. How'd you do question 3, lads? Maximum. Do dA. dA dr is 4 minus 2r. Slope is 0 when it's a maximum. That means your radius is 2. Your second derivative is 4, which is bigger than 0, which makes it a... Oh dear. Oh, sorry. Your second derivative is minus 2, which is less than 0, which makes it a max. Cool. Alright. So I did 2, 6, and 11. You guys are gonna do 3, 5, 7, 9, 10, and 12.